Welcome to the third lecture for the Mathematics Class 11, Chapter 8, Sequences and Series. So, till now we have seen what are sequences, okay, and what are the different types of sequences, examples of sequences. We also solved a few examples, okay, so related to are different kind of sequences that we can use. Okay, so just kind of a brief understanding of why exactly do we you know why do we think or why do we need sequences? Okay, in our day-to-day life. So mostly, as you have seen that with respect to sequences, okay, the major or the most the importance, okay, so the importance of sequences is found in the pattern that is being followed, okay, in the pattern or sorry, or sequential, okay, the sequential manner of the occurrence of the say terms or occurrence of the events. Okay, suppose we are even dealing with some events. So that how what does it help us? It helps us to in predictions, in different kind of predictions. Suppose you take a loan. Okay, so and obviously an interest is added to it every time. Okay, so to your principal amount, or there is, as we have spoken about before, the population as it is. Okay, so the rate goes on, if there is a certain rate, a specific rate that has to be added to your every year's population or every 10 years of population, the total population. So that helps us, if the predictions of events over time. Okay, it helps us in evaluation. Okay, evaluation as in by the end of this by the end of some interval, some time interval, what is going to be the how much amount is going to be there, or what population, the total population number, what it is going to be. Okay, so you can say evaluation of outcomes. Okay, evaluation of outcomes of events, it helps us in that. And most importantly, if you know the predictions and the evaluation, you can monitor it. Okay, so with respect to how we have seen that global warming is an issue. So if we can predict what is going to be the rate at which the temperature is going to change, and also we can evaluate that after a certain period of years, how what is going to be the total temperature change. So to reduce, maybe at least with respect to the global warming, if you want to reduce that effect, okay, so we can easily monitor the outcome. Okay, we can monitor the outcome because we can predict and we can evaluate. So for all these purposes, okay, so these sequences and series, like right now we are learning a very basic form of it, but eventually, if you go into more mathematical understanding and analysis, it will help us. Okay, so this is an important thing to remember, why we exactly need such kind of arithmetic understanding. And the another aspect would be your quantitative analysis, which that happens in financial assets, or for example the financial markets, and as well as when I spoke about the loans that we take. Okay, so in these arenas, we sometimes we mostly need the understanding of sequences. Okay, so before we go into the series part of the sequences, okay, so we have already seen examples of mostly, arithmetic, sequences. So mostly for arithmetic sequences, we will have a common difference D. Okay, so for arithmetic sequences, a common difference, sorry, D exists between two consecutive terms in a sequence. Okay, so with respect to this D, there are a few, formula that we know, that your A n plus 1 minus A n, okay, will give you your D. And also, or actually not, you can write it in the other way around, because that would be more understanding, like considering n as your this. So a n minus 1 gives you D, and any an, okay, any general term, you can get it as n minus 1 D. Okay, for any value of n, or even the last term. Suppose n is supposed to be the last number that you are asked, or last position of the sequence. Okay, so you can find your last term, or any for any value of n. Okay, so these two are important formula. So now let's see, the question that can be asked is 3, 8, 13, 15, 23, 28 an arithmetic sequence? If yes, find the formula for the nth term, and also find A101 term. Okay, so let's see if it is an arithmetic sequence. So for arithmetic sequence, we saw that a common difference should exist between two consecutive terms. Okay, so let's see if there is a common difference between two terms of the sequence. So let's take 8 minus 3, so that is 5. Okay, now let's check for the next two terms. So the next two terms will be 13 minus 8. Okay, that itself is 5 again. Can you check another one? This is also 5. Okay, so we can see that your D is actually 5 in this case. Okay, now if we know our D, now we will find our nth term formula for the sequence. Okay, so because of this, since we have a common difference D, we can say the first part of the question A, 3, 8, 13, 18, 23, 28 is an arithmetic sequence. Okay, and now we'll find the next part. So that is the nth term formula for the sequence. So for A n, so this is our formula. So we know our A1 is 3. Okay, so we have 3 plus, we will keep the n now, because we want to find the general form of this, and D is 5. So you have 3 plus 5n minus 5, and that is going to give you, okay, you for now we can just keep it like this, because then it would be, it's easy. Otherwise, you'll get a negative sign at the start. Okay, so this is your nth term formula. Okay, now the third part of the question was that we want to find A101. Okay, so where your n is equals to 101. So A101 can be written as A1 plus, so this will be 101 minus 1, and our D is 5. A1 is 3 plus n minus 1. Now this becomes 100 into 5. So this is 503. Okay, so your A101, okay, so 101st term of this sequence is going to be 503. Okay, so this is how we can find whether, if you are asked, like whether a certain sequence is arithmetic in nature or not. Okay, suppose, okay, suppose another question is given to you that we have 1 minus 3 minus 7 minus 11 minus 15 minus 19 and minus 23 as the sequence. Okay, find the nth term formula and find A11 and A12. Okay, let's say. So now again we have to find the D, the common difference, because our nth term formula is given as an is equals to a1 n minus 1 d. Okay, this is what we have. Now we have to find our d. So let's take d is equals to, say, a2 minus a1. Okay, so d then becomes your minus 3 minus 1 is minus 4. Let's see if the same difference is coming if we subtract two other consecutive numbers. So suppose you take a3 minus a2, so that is minus 7, and you have minus 3 as a2, so this becomes plus 3, and this again becomes minus 4. Okay, so our d is equals to minus 4. Okay, so this is this we have found. Now your an will be a1 plus, now we will substitute for a1 and d. So you get a1 we had as 1, okay, plus n minus 1, and our d is minus 4. Okay, so we can open the brackets and then we get it as 1 plus, sorry, plus over here. This is 1 minus 4n, okay, plus 4. So this eventually gives you minus 4n plus 5. Okay, now this we got as an is equals to minus 4n plus 5. Now let's just substitute directly for our different n's over here. Okay, so this we know is our nth term. So therefore your a11, okay, when your n is equals to 11, you can straight away write it as minus 4 into 11 plus 5. Okay, so that is minus 44 plus 9. You will have minus 49. Okay, and then we have A12. So A12 becomes minus 4 into your n is 12 over here. Okay, so into 12 plus 5. Okay, so this is 48 minus 48 plus 5. Sorry, this will not be minus minus 49. I made a mistake. Sorry. So this will be minus 44 plus 5. So this is actually minus 39. Okay. And similarly over here, this will be minus 43. Okay. So these are our A11 term, and this is our A12 term for the sequence which is given here. Okay. And the nth term will be always be given in this form. Okay. For when we have arithmetic sequence, okay, arithmetic sequence has in that there is a certain number added or subtracted from one term to get the next consecutive term. Okay. Now let's take another example. Suppose the question is if A1 is equals to 1, A2 is equals to 1, A3 is equals to 1, and an is equals to an minus 3 upon an minus 1 plus an minus 2. Okay, and for n more than or equal to 3. Okay, and the question or what we have to find is list the or list up to 7 terms of the sequence. Okay, so suppose we have already got the first 3 terms. Okay, so your A1 is equals to 1, A2 is equals to 1, and A3 is equals to 1. What we now want is from A4 to up to A7. Okay, and we have been given the general or the nth term formula has been already described over here. So we can get this as A4 is your an minus 3. Okay, so 4 minus 3. So you will have A1 upon an minus 1. So this is A3. And then you have an minus 2. So that is A2. So this will be 1 upon 1 plus 1. So this is 1 by 2. Okay. Now suppose we do the next one. So that is A5. Okay. Now A5, you will have n minus 3. So that is A2. And then you have n minus 1. So 5 minus 1 is A4. And the next term would be an minus 2. So 5 minus 2, 3. So you have A3. Okay, so A2 is 1. And your A4 that we had 5 is 1 by 2. And A3 is 1 again. So this actually comes out to be 1, 3 by 2. Okay, so then your A4 actually becomes 2 by 3 when you take this, up to the in the numerator form. Okay, so if you get the denominator of the denominator itself in the numerator, so this is what we get. Now we have to find up to 7 terms. So let's find A5. So A5 again you have an minus 3. So 5 minus 3 is 2. And then you have an minus 1. So that is A4. Sorry, we have done A5. We have to find A6. Yeah. Okay. So this is A5. So I'll just write it below A5. Yeah. So A5 is equals to 2 by 3. Okay. Now we have A6. So 6 minus 3 is A3. Upon you have A5 because n minus 1. Okay, and then you have plus A4. So then this becomes 1 upon your A5 was 2 by 3 and your A4 was 1 by 2. Okay, so now what you get this as is 1 by 7 plus, 7 by 6. Okay, so your A6 then becomes 6 by 7. Now, suppose you have A7. Okay, so A7 we can get as 7 minus 3, so A4 upon your A6 we have got as 6 by 7 and your A5, okay, because you have n minus 2, so your A5 was 2 by 3. Okay, so your A4 was, let's just write this and then I'll substitute A6 plus A5. So that is half in the numerator and 6 by 7 plus 2 by 3 in the denominator. So this is actually then going to become 21 by 64. Okay, so this is what we get. So these are, some very, these are simple, but still these are very conceptually important to understand. Okay, when we are trying to solve for sequences and series. So let's take another example. Okay, so we had learned about, Fibonacci sequence, just in a very small, in a very brief way. Excuse me, just a moment, I'll have some data. Okay. So we did see a very unique kind of a sequence. Okay, as an example, that was the Fibonacci sequence. So what was the Fibonacci sequence? Suppose you are given the Fibonacci sequence. Okay, where your first two terms are both equal to 1. Okay, and the general form of the Fibonacci sequence where your nth term can be written as, okay, an is equals to an minus 1 plus an minus 2. Okay, and over here your n is going to be more than 2. Okay, find. So we will try to find. So therefore, find an plus 1 by an for n going from 1 to 3 all the way up to 7. Okay, so now we have the Fibonacci sequences, the base. Okay, so we have the first two terms and we also have how we can find any of the nth term. And using these numbers in the sequence itself, for every different value of n, we have to find we have to evaluate an plus 1 divided by n. Okay, so the result for those. So let's quickly do so up to 7. Okay, so we need to find up to your 7. Okay, and also we can see that if your an becomes a7, you need all the way up to a8. Okay, for this part of the evaluation. So let's find all the way from, say, we will find terms from A3 up to A8. Okay. So let's see your A2 is equals to A1 is equals to 1. Okay, so now when we have A3, we have been given the nth term formula over here. So an minus 1. So that is 3 minus 1 is 2. And you have to add your you have to add the number previous to this A2 also. So that becomes A1. So this is 1 plus 1. So this is 2. Okay, so our third term is 2. Now let's see what would be A4. Okay, so that again by taking this formula into understanding over here, so we can get A4 is equals to A3 plus A2. So that is going to be 5. Okay. Then you have A5. So A5 would be A4 plus A3. Okay. So that is going to be, sorry, this will be 3. Yeah. That's I think I made it's a mistake over here. Okay. So A3 is your 2 and A2 is 1. So this is actually going to be 3. So now your A4 plus A3 will be 3 plus 2. Okay, so that is going to be 5. And then you will have A6. Okay, so A6 will be is equals to A5 plus A4. Okay, so A5 was what? A5 is 5 plus A4 is 3. This is 8. Now we want to find A7. A7 would be A6 minus, plus A5. So what is A6? A6 we have already got as 8 and A5 was 5. So this is what? 13. Now let's take A8 because in the other part of the question we have to find the values for an plus 1 upon an plus 1 upon an. So A8 then becomes A7 plus A6. Okay, so A7 is 13 and this is 8. So this would then become 21. Okay, so this is the Fibonacci series. So the series that we get now is 1, 1, 2, 3, 5, 8, 13, 21. Okay, and so on, but we are considering only up to the 21, these, the 8 terms over here. Now we have to find what? An plus 1 upon A1. Okay, so for say n is equals to 1. Okay, so then this will be A1 upon A2. So A2 by A1, what would that be? That would be 1 because your A1 and A2 both are equal to 1. Okay, so now for n is equals to 2. So that is A2 by A3. Okay, so A2 by A3 is again going to be 2 by 1, so that is 2 itself. Then we will have the next one would be A3 in the denominator and A4. Okay, and this would give us A4 that we had got was 3. Okay, so 3 by 5. Okay, so this is your A4 by A3. Then you have A5 by A4. Okay, so A5 by A4, your A5 was 5 and 3. So you can leave it at this one itself. And then you have for A6. Okay, for A6, what you have is is equals to a raised to 6 upon a raised to, a raised to 5 upon a raised to 6. So a raised to 5 we had got as 5 upon your a4 is 3. Sorry, we are finding for a6. I think I missed writing the n values. Okay, so over here your n is equals to 3, your n is equals to 4, and this is for n is equals to 5. Okay, so this actually should be 5 and this should be 6. Okay, n is equals to 5, a5 upon a6 upon a5. Okay, so your a6 is 8 and your a5 was 5. Okay, so this is what we get as 8 by 5. Now we have to find for when a or your n is equals to 6. Okay, so you can write 6 and n plus 1 becomes a7. Okay, so a7 is 13 and a6 is 8. Okay, so this would be 13 by 6. Okay, and then you have n is equals to 7. That's the last one that we want to find. So you have a7 and a8 on top. So a8 is 21 and a7 is 13. So this would be 21 upon 13. Okay, so you see that it is easy for us to find such sequences. Okay, even with Fibonacci sequence, you can find lot more terms ahead. And if you are given some other kind of expression that you have to evaluate, using the terms of the sequence itself in any kind of a combination, you can do that too. Okay, so now just a moment. Okay, so let's start with what is a series now. Okay, so we have seen different kinds of sequences. Now we will see what are series. Okay, so series is nothing but the sum of the terms of the sequence. Okay, so what is series? Sum of terms of a sequence. Okay, so this is what we know about series. So if a1, a2, a3, a4 all the way up to an is a sequence, the sum of the series is a1 plus a2 plus a3 plus a4 all the way plus up to plus an. Okay, so this is what we saw. Now in the sense of, say the Fibonacci sequence up to say the 8th term. Okay, so for example, 1, 1, 2, 3, 5, 8, 13 and 21. Okay, so if we have this, your series or Sn, if you know, okay, the sum of the series Sn is can be then written as 1 plus 1 plus 2 plus 3 plus 5 plus 8 plus 13 plus 21. Okay, so if you evaluate this, what you get is 2 plus 2, 4, 4 plus 3, 7, 7 plus 5, 12, 12 plus 8, 20, 20 plus 13 is 33, 33 plus 21 is 33 plus 21 is going to be 64. Okay, so this is where or how we utilize the concept of series. Okay, so series is nothing but the sum of the all the terms that are given in the sequence. Okay, so now your series can be finite or infinite. Okay, so for this you need finite sequences, and this will have this will be for infinite sequences. Okay, so this is the difference. Now we know that for with respect to the sequences that we have seen, if we have if it is an arithmetic sequence. Okay, so you will have D and you will have N and you will have one A1. Okay, so and you will have up to N terms. Okay, so therefore sum of the first N terms is equals to, okay, you can write it in a more concise form. So that is, sorry, this is yeah. So this is N by 2 multiplied by 2A plus N minus, so you have 2A plus N minus 1 D. Okay, so this is something that we will have to remember. Okay, so there is a general way of finding the sum of the first N terms. Okay, suppose you're just given the value of N and you have the value of D. So you can easily solve for the first N number of terms. Okay, that is there in the sequence that we are dealing with. Okay, so but as you can see that this is only applicable for arithmetic sequence. So when we will slowly later on see the geometric sequence or geometric progression, we'll see how the this formula actually changes with respect to that. Okay. So let's take an example of, okay, so the question is, suppose your A1 is equals to say 4, okay, and your an is going to be 3an minus 1 plus 2. Okay, so this is our nth term of sequence. Okay, so find first 5 terms and then find the sum of the series. Okay, so before we go into the series, we need to know obviously up to the terms that is being asked in the series portion. Okay, so the first one you will have A1 is equals to 4. Okay, now you have A2 is equals to 3 into an minus 1. So 3 into A1 plus 2. So this will be 3 into 4. Okay, so that is 12 plus 2. So it is 14. Then the next one that we have is A2 is equals to your A2 is done, A3. So A3 is going to be 3 into your A2 plus 2. So A2 is now 14. So 3 into 14 plus 2. So this is actually 42 plus 2. This is 44. Okay. Then you have A4. So A4 then becomes 3 into A3 plus 2. So that is 3 into 44 plus 2. So that actually becomes 3 into 4 is 12. So 12, 132 plus 2. So this is 134. And the last term we have to find up to the fifth term. So this is A5, and that is 3 into A4 plus 2. Okay, so you have 3 into 134 plus 2. Okay, so this will be 402 into 2. So that is going to be 408,804. Okay, so these are the different terms that we have. Finally, some of the series of 5 terms. Okay, so we are only considering the 5 terms that we've got. So therefore, your series is then going to be 4 plus 14 plus 44 plus 134 plus 804. Okay, so now you have this as 18. 18 plus 44 is 12. 12, 1, 5, 6, 62. Okay, so then this is going to be your 6, 9, 196. And this is going to be 0, 1, 0, 1. Okay, so the sum of the series, with respect to your A1 is equals to 4, and then you also have the different, ANs. So this is going to be 1000. Okay, so SN is your 1000. So you can see this is how we can find the series. Okay. Now, yesterday we did few sum. In the last class we did a few sums of different kind of sequences, the examples. So suppose we take one of them itself, okay, and we can now find the series for those. Okay. So there was one question with AN is equals to 2n minus 1 by 6. Okay. And we actually had got our D also. D, we had got it as 1 by 3. Okay. So therefore, our AN then actually was, okay, so our AN is A1 plus n minus 1 D. Okay, so this we could get. So actually, our A1, which we had got, was, if you get it in this, okay, an is equals to 2n minus 1. So not taking this into account, we have already got a general nth term formula, okay, in the question itself. So our a1 was 2 minus 1 by 6 is 1 by 6. Okay, so we have got our 1 by 6. Now let's take the, because now we don't want to find all the terms again. Okay, we just want to see the sum of the series for this. So the formula that we have for the sum of the series, okay, for any such arithmetic, where you have your arithmetic sequences, you can directly solve it as Sn is equals to n by 2, 2a plus n minus 1 d. Okay, so now suppose we had found up to the fifth term. Okay, so let's just say find Sn up to fifth term. Okay, so our n becomes actually 5. So you have 5 by 2. Okay, multiplied by 2 into this a is actually your a1. Okay, so a1 is what? 1 by 6. Okay, 1 by 6. And you have plus, you have n again. So 5 minus 1. And our d is 1 by 6. sorry, 1 by 3. Yeah, our D is 1 by 3. Okay, so this is what we get. Now, if you solve this, okay, so your 2 and 2 gets cancelled. So this is 5 by 6. Plus, if you multiply 5 by 2 over here, so this would be 5 by 2 multiplied by, you have 4 by 3. Okay, so we have 4 by 3. So this actually ends up being 2. So this is 5 by 6 plus you have 10 by 3. So this you can easily write as 5 plus 30 upon 6. So this is 35 by 6. Okay, so your SN then becomes 35 by 6. So it was easy for us to calculate when we have been given D, we have been given, you can find your first term if it's not given from the, the general term that is described for the sequence itself. Okay, you can use that too. So let's take another example that we had taken in the last class. Mhm. So let's take the question that we had was, okay, so the question we have is A1 is equals to 1, okay, and your AN is equals to AN minus 1 plus 3, okay, and your N is more than 3. So suppose we find, okay, so we will say find the sum of the series up to 5th term. Okay, so we are going to take your N is equals to 5. Okay, so and if we want to find the D that we have. Okay, so how do we find the D? So let's see, your A1 is given. Okay, so let's take A2. So your A2 then becomes AN minus 1. So that is A1 plus 3. Okay, so A1 is 1. 1 plus 3 is equals to 4. So let's just take another one. So A3 will then become A2 plus 3. So over here that becomes A2 is 4. 4 plus 3, 7. You can see from the formula itself and also, kind of the numbers that we are getting. So your D is going to be A3 minus 2, A2, and it is also going to be equal to A2 minus A1, and that is going to be 4. Okay, so because you have 4 minus 4 minus 1, or you have 7 minus 4, so that is going to give you 4. Okay, so now if you want to find the series, you have Sn. Okay, Sn is equals to n by 2, 2a1. Okay, even if you write 2a or 2a1, that only means that the first term that we have to write. And then you have n minus 1 d. So your n, okay, so we have, we want to find up to 5 term. So 5 by 2. So 2 into 1 is 2 plus your n minus 1. So that is 4. So 4 into 4 you have, oh sorry, your this D is 3. It's not 4. I'm sorry, this is going to be 3. Okay, so 4 minus 1, 3. And 7 minus 4 is 3. Okay, so now you have n minus 1, so that is going to be your 5 minus 1, so that is going to be 4 multiplied by 3. Okay, so you multiply, so in the first term your 2 and 2 gets cancelled, you have 5 plus you have 2 will also get cancelled, 2 and 4 will get cancelled, so 5 into 2, 10, 10 into 3 is your 30. So this is your 35. So you can see that it is easier to calculate the sum of the series, like by not finding all the terms up to the 5th term, and then calculating it. Okay, so it is easier in this form where we have a direct formula for this. Okay, so we will stop here for today. In the next class, we will continue with series and we'll solve a few more examples with respect to that. So thank you so much for attending.